I'm Anil Kumar, and in this video we will understand how to analyze critical points for a piecewise function. Question here is, consider the function f of x equals to 2x plus 9 when x is less than or equal to minus 3 and x squared plus 1 when x is greater than minus 2. Let me correct this, it should be greater than, right? So we could use only at one place. Okay. Find all critical numbers of f of x and determine whether each corresponds to local maximum, a local minimum, or neither. So that is the question for you. In the case of piecewise function, I'd like you to sketch the function first. So let's try to sketch it. So let's say that's the coordinate plane. So we have two pieces joined together at minus 2. So let us consider let's say this is minus 1, minus 2, minus 3, minus 4. So let's say this is minus 2 for us. So these two pieces are joined together at minus 2. So let's find the value of the function at minus 2. So if I substitute minus 2 here, I get 2 times minus 2 plus 9, which is minus 4 plus 9, which is 5. So at minus 2, the value of the function is 5. Let's say this point represents 5 for us. Now, when the function is less than minus 2, it is a straight line, correct? So we can draw a straight line from here. Just to find another point, what you can do is you can find the x-intercept, which is at minus 4.5, right? So let me sketch the function here. So from here, let us say kind of like this, right? So that becomes a function. Let me extend this. Okay. So this point will be 4.5 with a negative sign, right? That becomes the x-intercept. Now on the right side of minus 2, it is a parabola. If I substitute minus 2, then I do get a hole here, right? So for that value, let me use a different ink to sketch it. So what we will do is, at minus 2 square is 4, 4 plus 1 is 5, so we kind of get the same point, right? So it is a hole, but it's the same point. And it's a parabola opening upwards, where the axisymmetry is at 0. So the minimum is at 0. So it will be a parabola going upwards like this. Correct. X equals to 0 will give us a value of 1. So that is the kind of function. Once you sketch the function, it is simpler to solve piecewise function. That's the whole idea. It's not difficult to sketch these functions. Do you get the point? So it is not asked for, but it is better to do. Okay. Now let's read the question once again. Consider the function, find all critical numbers and determine whether each corresponds to local maximum, local minimum, or neither. Right? So you have your answer right there. You have local maximum at minus 2, local minimum at 0. But we will now adopt the strategy which we have learned, that is to find critical number. Find critical number. Right? Once you find critical number, then we will figure out whether it is a local maximum or not. So at critical number, the derivative of the function is either 0 or undefined. So that is the critical number. So to find the derivative, let's begin by finding the derivative itself of this piecewise function. This piecewise function derivative is x 2x plus 9. Derivative will be just number 2, right? And for that part, it will be 2x. Now 2 is the derivative when x is less than equal to minus 2. So we'll not consider the boundary condition in this minus 2, right? So we know at that point, since it is one side defined, so when you find derivative, it is on the right or left side of that boundary condition, right? So we'll say less than 2. It is 2 when minus 2 is less than x. That's critical to understand, right? Now at this point, you're joining these two. So critical numbers are also the numbers at the boundary, right? So from here that, and plus we need to consider the boundary. Boundary condition here is x equals to minus 2. You can see x equals to minus 2 is your boundary condition. So here you also see it is undefined. Perfect. So that is how it is. Now from here we can say the critical numbers are x equals to, this part will be 0 at x equals to 0, that is 1, and x equals to minus 2. You could say that from your graph being a kind of a sharp edge corner, or because of the boundary. So I'll write here boundary condition, right? So that is how you find your critical numbers. Now let us analyze on either side of the critical numbers whether the function is increasing or decreasing. So we will now analyze increasing and decreasing intervals. So we'll do increase and decrease intervals, right? So that is what we are going to analyze now. So for increasing and decreasing intervals, we'll consider the critical numbers. The critical numbers for us are at 0 and at minus 2. So let us take a test point. So if I take a test point, I take minus 3 here, minus 1, plus 1. So that becomes my test points. And what are we testing? We are testing the derivative, right? F prime x. Now, if I write minus 3, right, in this, I do get plus 2 value. So this is positive. This is always positive, and therefore the function is increasing. Do you see that? It is positive 2, always positive. Derivative after minus 2 and between 0, if I write minus 1, I get negative. So I get a negative value here, right? And if I write a positive value, I get 2 times the positive value, which is positive, so it is increasing. So from this analysis, it is very clear that I have relative, or you can say local or relative minimum, right? So that is my relative minimum. And this is my maximum, right? So which is relative, or you can say local maximum, correct? So from the analysis of increasing and decreasing intervals, we get our answer. So we have, so that is how we could answer it. So the solution here is the local or the relative, so local maximum is at minus 2, 5, and local minimum is at 0, 1. Correct? So that is how we can answer this particular question, right? So, and we have these two as our critical numbers. I hope that helps you to understand how to solve such questions. Thank you and all the best.